Hello, you're welcome to the PY 101 class. In this class, we are going to be making use of Jupyter Notebook and Spider. Before you can make use of Jupyter Notebook or Spider, you have to have Anaconda installed on your computer. If you do not have Anaconda on your computer, or if you do not know how to install Anaconda on your computer and how to use it, please watch the previous video where I walk you through how to install Anaconda on your computer and make use of it. When you have Anaconda installed on your computer, automatically it installs Python. Now let's move on to Python basics. Before we talk about the building blocks of Python, what is a computer program? Most of us believe computers are intelligent, but in all honesty, a computer will only do what you ask it to do. And that's where a computer program comes into play. A computer program is a set of instructions given to a computer to execute in a certain order. This computer program could be long and complex, but it's always good to keep things simple. The act of writing instructions to the computer to execute is known as programming. Before you can write a program, you need to use a programming language. There are numerous programming languages in the world. Let me tell you today, programming languages are categorized as either high-level programming language or low-level programming language. Python is a high-level programming language. What is the Python programming language? So the Python programming language has a syntax rules for writing a valid program. What we understand by the word syntax? Syntax rules just means like grammar rules. Like in English language, to be able to construct valid sentences, you have to follow the grammar rules. So in Python, for you to be able to write a valid Python program, you have to follow the syntax rules. So there are certain rules for you to follow in order to write a valid Python program. And that's what we'll be covering in the Python basics. Before you can execute a Python program, you need to have Python downloaded and installed on your computer. And why is this so? That's because computers only understand the machine language. And what's a machine language? A machine language is a set of zeros and ones. And when you write a computer program using a Python programming language, you are just writing a set of syntax rules, of which the computer does not understand. So when you install Python on your computer, automatically install the Python interpreter. It is the job of the Python interpreter to interpret the Python program to the machine language equivalent, that is a set of zeros and ones, for the computer to understand, so that the computer can execute the instructions given to it. Now, let's look at arithmetic operators. We all know about mathematical operators. Now, we can also use mathematical operators in Python. Just like I've said before, Python has its syntax rules. So each of these mathematical operators, which we know in mathematics, have its own syntax in Python. The simplest computer program you can write is an expression. And what is an expression? An expression is just a combination of operands, which are also known as values, and operators. And operators are what? Could be mathematical operators, which we call arithmetic operators. It could be logical operators. It could be Boolean operators. We'll talk about logical operators, Boolean operators later on in the course. But now, at the moment, we're going to focus on arithmetic operators to write expressions. Expressions evaluate to a single value. In mathematics, when you have a long expression to solve, which comprises of maybe addition, subtraction, multiplication, and all that, after solving it, it results to what? A single value. You get a single value as an answer. So that's what an expression. Remember, I said Python has its syntax for arithmetic operators, which you can see displayed on the screen. Now let's look at it one after the other. So the first arithmetic operator we're going to look at is addition. Python uses ++, plus, just as we see in mathematics for addition. The next one we're going to look at is subtraction. Python syntax for subtraction is minus, just as we see in mathematics as well. We're also going to look at multiplication. Unlike mathematics, where we use the small x to denote multiplication, in Python we use asterisk. We also have division. The Python syntax for division is a /. Aside division, the normal division we know, Python also has something it calls floor division. I'll explain that. And it denotes floor division with a double /. We also have modulus. If you're hearing modulus for the first time, I'll explain what modulus is, but Python uses the percentage sign to denote modulus. So that's the syntax for modulus, the percentage sign. Finally, we have exponentation, or what we call power. And Python uses the double asterisk for that. Now, let me explain what division, floor division, and modulus is. So the division, the one with a single /, it always returns a decimal number as a result. It returns a decimal. So it means that it's going to divide the numbers and give you the answer as a decimal. But floor division, what it does is that it gives you the answer as a whole number. So if there's any remainder or whatever decimal part it has, it's going to truncate it. It gives you just the whole number. Modulus, on the other hand, is like the opposite of floor division. Remember, floor division would give you the whole number when you divide two numbers together. If there's any remainder or any decimal part, it throws it away. Modulus, on the other hand, say, oh, you don't want a remainder, you don't want the remainder, I want it, it's useful to me. So modulus will always return just the remainder, it doesn't deal with the quotient. So when you divide two numbers together, whatever value that remains, when you divide those two numbers together, it's what modulus returns. So modulus always returns the remainder when you divide two numbers together. So don't forget, division will divide two numbers and return a decimal as a value. Floor division will divide two numbers and return just whole number as a value, that is returning just the quotient. Modulus will divide two numbers and return the remainder to you as a value. If you don't understand at this point, don't worry, we're going to see it in practice. So like I said earlier, the simplest program you can write is an expression. So let's look at some expressions. So in the first code cell, so what you can see now is a code cell. I've highlighted it as a code cell. So this is Jupyter Notebook I'm using. It's very interactive. It runs on IPython, what we call interactive Python. And that's why it's interactive. I can switch from notes to code, interactive Python. So here we've written an expression that adds two numbers together, that is 2 plus 2. So if I want to execute this cell, I want to execute this code cell and see the answer I'm going to get in return, I just need to click on the run button. You can see the run button at the top here. The run button, look at it over here, the run button, just click on it and you get the answer 4. Let's look at another expression, highlight it. So this is 5 times 3.5. Remember, in multiplication, the syntax for Python is asterisk, not the small x like we see in mathematics. So when we run this cell, we click on run, and it gives us the answer 17.5. Now, let's look at division. Remember, I told you this is a single /, which is division. So remember, I told you this division returns a decimal as value. So let's execute it. Another way to execute a code cell, apart from just pressing the run button at the top, is to use the keys Shift Enter. I'm going to use it here now. Shift Enter, and you can see we have our answer. So it gives us a decimal, 2.66666 blah 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 5. So that's a decimal. That's a decimal. Let's now see floor division in action. So we're going to divide same numbers, 8 and 3, But this time around, instead of using the division, that's with one with a single forward slash, we're going to be using the one with a double forward slash. And remember I said it returns an integer. So it's going to truncate the decimal part and just return the whole number, which is 2. Let's execute it and see. Yeah, you can see. So it returned the value 2. Let's see modulus on the other hand. Remember I said modulus returns remainder. Modulus always returns the remainder. So when you divide two numbers together, whatever value that remains, that's what modulus returns. Remember, when we divide 8 by 3, we would get 2, remainder how many? 2. So you can get 2 3s in 8, and there will be a remainder of 2. So let's execute that part. Yeah, and we got 2. We got 2. Now I have this code cell, and in this code cell you can see here I have 2 expressions in the code cell. Unlike in previous code cells where I had just 1 expression each. I've done this deliberately to point out something to you. Remember I said we're using Jupyter Notebook, and Jupyter Notebook runs on interactive Python. Before I execute this cell, let me explain what's happening to you. So in the previous code cell, you can see something called in with a number in front of each cell, and for the output displayed, you can see out with a corresponding number for the in. What this means is that for every input you have in a code cell, it's that input, whatever you write in the code cell, is being stored in a variable called in. And the corresponding outputs for that code cell, if it has any outputs to display, would be stored, if it has any value or any output, will be stored in a corresponding value, in a corresponding variable called out. We will still know what variables are. Variables are just like containers for storing values. We'll talk about it under this Python basics, so don't get confused yet. So for every input, it stores the corresponding output in the variable out. Now, you can see we've always had 1 input, 1 output. Now in this code cell, we have what? 2 expressions. Will IPython consider it as 2 different inputs, and will it give us 2 outputs, or will it consider it as just 1 input and give us 1 output? Let's check it out. Great. And now we've executed the cell. We are getting only 1 answer despite having 2 different expressions. So why is that so? And even the answer it gave us, which expression is that? It's actually not that of 5 times 3.5, because 5 times 3.5 gives us 17.5. Let's look at 7 modulus 3. Yes, 7 modulus 3 will give us 1. So it actually returned the answer for 7 modulus 3. When you divide 7 by 3, there's a remainder of 1, and that's why it returned 1. So why did it not print the answer of 5 times 3.5, but it printed the answer of 7 modulus 3? So basically, IPython can only store 1 output for every code cell. It's a one-to-one mapping. So even if I have lots and lots of expressions in a code cell, it will only give me 1 output, and that's definitely going to be the last output, expression, and that's why it's what printed the answer for the last expression, which is 7 modulus 3. Now there's a workaround for it. So if I can have 2, that takes us to the next cell. I can have 2 different expressions and still display both answers by using the print statement. Why? That's because the print statement is a Python inbuilt function that is used to just display values to the console. It doesn't really return any value per se. It doesn't return any value. All it just does is that it prints to the console. When I mean that it doesn't return any value, is that it doesn't return any value to the caller, like it doesn't store any value. So its values are not stored. It only displays to the output. So print returns a data type, a special data type called none. None means nothing. It's empty. All it just does for you is that, oh, display it. So with the print statement, we can now see both results, and you'll see something interesting as well. Good. As you can see, we have our results now, 17.5, and we have 1. But what else did you notice different? There is no out in front of it. And why is that so? Just like I said, the print function returns a non-data type. It means that it doesn't have any output apart from just displaying the result. So it doesn't have any output. And that's why for this code cell, for this input, there is no corresponding output that is going to be saved to the out variable. I hope you understand that. Please, if you don't understand that, drop your questions for me in the comment section and I'll give you answers. Thank you. Now, let's talk about order of operations. Order of operations. So sometimes we have expressions with a number of arithmetical operators. Probably the expression consists of addition, subtraction, modulus, exponents, parentheses. So how does Python know which one to execute first? That's where order of operations comes into play. Just like we've seen in mathematics, where we use BODMAS for order of expressions, for order of operations. In Python, it's called PEMDAS. It's similar to that of BODMAS, but with a little bit of difference. So let's look at it. So we have, in Python, we have PEMDAS, P for parentheses, which we also know as brackets, E for exponent, which we also know as raised to the power, M for multiplication, D for division, A for addition, and S for subtraction. So in Python, if you have any parentheses in your expression, Python is going to execute that first. It's going to execute that first. So you will use parentheses to make Python execute a particular operation first, even if the operation is actually the last in the hierarchy. Once there's a parenthesis, once that particular operation is enclosed in a parenthesis, then Python will have to execute it first, because parenthesis actually is top in the hierarchy. Next is exponents. So if there's no parenthesis, Python will check, is there any exponents? If there's any exponents, then execute the exponent first. Next. Now, one difference between BODMAS and PEMDAS is that in Python, multiplication and division are of the same order. So since they are of the same order, if we have both multiplication and division in our expression, how does Python know which one to execute first? Well, it's a matter of first come, first serve. So whichever Python sees first, when evaluating the expression from left to right, expressions are always evaluated from left to right. So whichever Python sees first in the expression, Python is going to execute it first. If Python sees division first, when evaluating the expression from left to right, Python is going to evaluate division. If Python sees multiplication first, when evaluating the expression from left to right, then Python is going to evaluate the multiplication. Also, same goes for addition and subtraction. Addition and subtraction also have the same order. And Python is going to execute whichever it sees first from left to right. Now, let's look at some of the expressions we can have in Python. Oh, sorry, I've executed this before, but let's just execute it again. So, we have 8 multiplied by 4 divided by 2 multiplied by 3. Remember, multiplication and division have the same order. So Python is going to execute whichever comes first. And remember, it's going to execute from left to right. So it's going to start from 8 and end at 3. So it's going to go this way. Python is going to go this way. Let's see it. So we have 8 times 4 divided by 2 times 3. So Python is going to do evaluating from left to right. Python will do 8 times 4 would give us what? 32. So it's going to have 32 divided by 2 times 3. So next on the line is division. So it's going to be 32 divided by 2, which is 16. So we have 16 times 3. 16 times 3 is going to give us 48. So back to our screen, when we execute this, even if I've executed before, you can see Python gave us 48.0 as answer. It returned a decimal. And why is that so? Remember, this single forward slash actually returns a decimal as answer. That's why it did that. So that's why it's returning a decimal. Now let's look at the next expression. How is Python going to evaluate it? Let's look at that. So in the next one, we have 2 plus 3 in parentheses times 5 modulus 3. So Python is going to do the one in the first parenthesis first. So 2 plus 3 gives us 5. So it has times the next parenthesis. So it's going to move on to the next parenthesis, 5 modulus 3. When you divide 5 by 3, you have a remainder of 2. So it's going to give us 5 times 2. And we know 5 times 2 is going to give us 10. So when we execute that line, we are going to have 10. 10. So feel free to try out various expressions, understand how PEMDAS works, try to master the syntax for arithmetic operators, and in the next class we're going to be talking about data types. I'm going to stop the class here so you don't have too much to consume in your first class. Thank you.